Methods in isolating Cronobacter. There are 3 methods that were first developed in isolating Cronobacter from a milk-based powdered formula. In these 3 protocols, pre-enrichment of the powdered infant formula samples to be tested is needed. Selective enrichment will be done, and the bacterial isolation will follow with a use of selective media. Typical colonies are then confirmed using a selective agar and/or a suitable real-time PCR assay with the final identification based on either biochemical or molecular characterization. Other selective media for Cronobacter had been developed based on the alpha-glucosidase enzyme marker and the beta-cellulobiosidase activity, which are all present in Cronobacter strains, some of which are listed below. The accuracy and reliability of commercially available identification kits for Cronobacter had been questioned because of the false negative and false positive identification. Thus, both the ISO TS 22964 and US FDA method are currently accepted as reference methods for identification of Cronobacter species. Immunoassay and molecular detection techniques were developed to identify Cronobacter in various levels, including the genus, species, and serotype levels. Immunoassay is a biochemical test that measures the presence or concentration of a molecule in a solution through the use of an antibody or an antigen. Antibody targets like IgG, IgY, and OMPA were used for the immune detection of Cronobacter. Recently, 2 rapid analytical methods were established for the detection of Cronobacter species, namely antiplatelet antibody-based indirect ELISA and a sandwich ELISA using a polyclonal and monoclonal antibodies. Molecular detection techniques were also considered in detecting Cronobacter. A real-time PCR protocol using a TACMAN-based design and cybergreen assay were reported to be highly specific, sensitive, and efficient methods in detection of Cronobacter species. Phenotype-based and DNA-based subtyping methods allows differentiation of bacterial isolates beyond the species and subspecies level. It helps in tracking, preventing, and regulating foodborne bacterial diseases based on genetic characteristics rather than the traditional species definitions. A number of molecular subtyping strategies had been applied for subtyping Cronobacter species, example of which are pulse-field gel electrophoresis, which had been widely used to track the movement of Cronobacter species. Multi-locus sequence typing, which leads to recent findings that sequence type 4 within Cronobacter sakazaki was responsible for a large proportion of severe neonatal infections. Multi-locus variable number tandem repeat analysis. Multi-locus sequence analysis. And matrix-assisted laser absorption ionization time-of-flight mass spectrometry. Currently, pulse-field gel electrophoresis and multi-locus sequence typing approaches are the most widely used.
created using Powtoon.